Hey all, welcome back to the lab. In this video, we are talking about Advent of Code 2024 Day 3 using F#. I'm a little late on this one today, so I'm going to try to catch up here and then also do Day 4 and post it hopefully later today. Now, as a reminder, Hominions members do get full access to the project files, so you can get clone and run it yourself, but we'll also be going through the full source code in this post, so you can copy and paste it and review it as well. All right, so Day 3, Part 1. So the prompt here, if you want to take a look at it, but it's long, so we're just going to go into my summary that I used to solve this problem. And so basically we're given a bunch of jumbled instructions. And to give you an idea of what this looks like, it's just like a bunch of like random stuff, it looks like. But obviously there's some key terms and stuff in here that we're trying to pull out. So just a bunch of random stuff is input. And basically the ask is to find valid instructions. And the valid instructions are a form mul x, y, where x and y are numbers. And so critically, like, it has to be in this exact format. There can't be spaces, there can't be letters in here, there can't be like special characters. It just has to be this form, and x and y are numbers. And then they want to sum all of the values of this. Values here really means like the sum of the product. So you evaluate this, if you will, and then sum those together. And so we have a few sub-problems here. And the first is like, how do we find the valid and invalid instructions? And so when you look at something like this, when you've got like a ton of random characters and you're looking for a specific pattern, regex obviously comes to mind because this can precisely describe the valid commands and pull them out. Of course, one of the downsides of regex is that it's kind of like a crazy syntax and it can quickly get very complicated and it's almost impossible to figure out at a glance if this is doing what you think it does. But, looks like a regex problem from the outset. And of course, another way you could do this is do your own version of parsing. So you could do like raw string parsing. You could try to do some sort of like AST thing so that you're like doing some sort of hierarchical thing. But, building your own parser can quickly also get complicated with lots of logic. And so for these daily problems like this, you may or may not want to do this since it would be throwaway at the end of this. And basically my takeaway here is that the required regex to just get out like a mul xy is pretty straightforward, and so it's probably better than trying to build our parser, at least for part 1, because we don't know if part 2 will be a lot more complicated. The next is summing the products of the values, and basically once we have the mul statements and pull out xy, we can just multiply and add them. This one's pretty straightforward. And so the solution I wanted to go with is basically just pull out all the multiply instructions and add the products. We will use the regex to pull out the multiply instructions because that seems simpler. Theoretically, this should be around O of n because the regex is pretty straightforward, but you always need to be careful because especially if you're using like look forwards or look backs, it can quickly turn into like a lot more expensive, and regex is kind of like abstracted from you, so you don't really know what's going on in there. So I think it's around O of n, but you always got to be careful. And then we'll just sum the products, which can also be done in O of m, if you will. Okay, so that's the general approach, and here's the code here if you want to copy and paste it, but I'll open it up in my editor so we can get some syntax highlighting. All right, so here we are in Day 3, and I've got a few helper functions here, but let's go to solve part 1. All right, so let's start with like the skeleton of this to give you an idea of like how we're actually running through this. So, we'll call it, it'll print out its running statements, and then it's going to say, read all the input text, and then read all the mul values from the input text. And then we're just going to, this will return a list of tuples and int, so this will be x, y, and then we'll just sum by this and then just do the multiplication here. And so that's, how we're accomplishing this thing. Of course, all of the complexity is actually abstracted in these, so we'll take a look at them. So read all input text, basically, we're just finding the file where we're keeping the inputs. This is where I put them in my static folder here, Day 3 input. And then I just am reading all the text out here to keep things simple, and then we just return the full string here. So after we get that, we pass it into this read all mul values from input. And here we can see that we're using regex pattern. It's pretty straightforward. Basically, it needs a mul. It's matching on a parenthesis literal here, and then it's ensuring that this is all decimals, at least one or more decimals, and that this is one or more decimals as well, and returning this. To get the matches, we're using regex.matches, and then we basically map over the matches, pull out the first group's value, which will be x, and then the second group's value, which will be y, and then we return it as a tuple so that we can uniquely identify them, and then we would just return it as a list. So that's how we do problem 1. Relatively straightforward so far. this was my answer here, which got accepted. How can I show you this? Here, accepted here. Got both stars. So it seems to work all right. Okay, on to part 2. So, full prompt is here, but we'll just walk over my summary of this. So given we have the same input as above, but the ask now is to sum the products of mul instructions. And so we still have the valid instructions as this mul xy. However, we now have an idea of enabled or disabled. And so basically, if there's a do, then everything after that, unless there's like a new instruction that changes things, is enabled. And everything that's after a don't is disabled. And so you can imagine that the input can be like enabled, disabled, stuff like that. And we only want to use the muls from the enabled section. And so basically the new subproblem that we have to solve here is how do we find enabled and disabled sections? And so, the original version of this was to use a regex, and so the first thing you'll probably think about is to use a regex here as well. And you can do this, but this is one of those cases where you start to add in the look forwards, or I guess look backs here, and you try to find like the most recent thing. And this regex starts getting very complicated, and you have to catch for like all edge cases where like if it's a do don't kind of thing, only get the latest thing. And this is one of those cases where, it probably starts to spin out of control so that it's not O of n. You start to get who knows what inside of regex. And in prod, whenever I see a regex like this, I'm like, there has to be a better way, because it's just almost impossible to debug if something goes wrong. And so you could do a big old regex, but I usually try to avoid these whenever they start to get complicated. Now, another thing we could do is like, we know that we already have an ability to take a string and pull out the muls, right? And really all we have are sections of string that are enabled and disabled. And so what we could do is just pre-process the string so that we separate the enabled and disabled sections, and then we only do the function we already have for pulling out muls and processing them on the enabled sections. And so basically what you do is you'd pre-process enabled versus disabled by just looking at like, oh, here's a do from the first do to the first don't. This is, enabled. And then we go find the next do after that. And then that do to the next don't is enabled. And those are the only sections we actually care about, because everything that's not in those sections is disabled, and so we can just toss it. It's just useless information to us. And so we can pre-process these, and then we only keep the enabled sections, and then we can run our mul regex that we created earlier on this to get the answer out. And so basically the algorithm for this is something like this. So you find all don'ts, you find all do's, like the index there. Then you can parse over the indexes, finding the sections where they are enabled or disabled. Again, this is like the first do to the first don't enabled, and then you got to find the next do after that. And then you kind of do like a sliding window like that. And then we are creating a new string with just those enabled indexes together. So you like substring a few times, and then you just pass those into the mul processing and sum by that we had earlier. And basically this only adds an extra O of n in here, because we just have like, I guess several n's, like 4 or 5 n's, but relatively straightforward linear time adds here. So here's all the code. I'll warn you that it is a little bit complicated. I'm not super proud of this code, but it does seem to work, so we're going with it. So you can take a look here, but then I'll open it in my editor so we can see better. Okay, so here's part 2, and I've got a bunch of little helper functions. It's pretty long. Here's the entry point. And it looks basically the exact same as our initial code for part 1, right? What we're doing is we're reading the input text, we're reading the mul values out, and then we're doing the sum by. The only difference is we are pre-processing this input text here by saying get enabled input sections. And then we are combining those into a single string just so that the types are the same here for simplicity. So basically everything's the same except for this function. Unfortunately, this function is a little bit complicated. And so basically what we're doing is, we're creating our don't string regex and our do string regex, so we know what we want to look up. And then we're just pulling those out. So we get all of the don't starting indices from our string, and then we're doing all the do indices from our string, just so we have those already. And I have some debug statements because this took me a while to figure out. And so then we have to do the sliding window thing of like finding the enabled sections. And basically an enabled section is a do to the next don't, and then a don't section is don't to the next do. But really this means that all we need to care about is finding these enabled sections, because by definition, anything that's not enabled section will be disabled. And so we'll do this sliding window thing of, we'll find the first do, and then we'll find the first don't after that. That's an enabled section. And then we're going to mark, we've already parsed everything in the string up to this don't point. And then so we restart. We find the next do after this, and then we find the next don't. And that's how we're going to find these sliding windows of enabled sections. This code is super imperative. I assume there's like a nice, elegant, functional way to do this, like finding the pairs of the indices or something. I could not think of a version of this. So we just reverted to imperative because this is like, your standard medium LeetCode sliding window issue. And so that's how I've solved these in the past. Okay, so the first thing I do is I precede these with the first section, because the problem statement says that this starts out enabled. It's enabled until the first don't. And so iterating over the sliding window directly in the iterator I have here, it won't work because it only is looking for do to don't. And so we have to precede with, all right, first section until the first don't, that is enabled. And so that's what we're doing here. So do index will start at 0, but don't index will actually start at 1 because we already processed 0. The 0th index of this, the process string index, will be to where the next don't is, because we've already processed that first section, so we don't need to process it again. And we're going to precede all enabled indices here with 0 to first don't index, because that is an enabled section that we do want to look for moles in. And now basically we have to start our iteration over these enabled sections. And so basically we're just doing a while loop of, while our do index is less than all of our do indices and our don't index is less than all don't indices, then we know that there's like a new section that we need to find because we have an extra one of each of these. And then what we're going to do is we're going to start these off as 0. There's probably a cleaner way to do this. This is what I went with. And basically what we're going to say is we're going to iterate through all the do's until, while we actually have a next thing to look at, and while the next pointer in the string is less than or equal to the process string index. So basically we're going to keep going until we have a do that's after, or I guess is in part of the string that we haven't processed yet. The reason we have to do this is because some of the input strings will have like many do's after each other, and so you can't just take the next one. You actually need to look for one that's not processed yet. And so we're basically trying to take the next one that is not processed. There's probably some edge cases here as well that I'm not covering, but it worked for my input. But my guess is that there are some edge cases here as well. But, it's fine for now. And then we're basically doing the same thing for the don't pointers. Basically, we're saying like, okay, while we actually have a next don't index to look at, and we're either in part of the string that is not processed yet, so then we have to get to a part that, while we're in a part that is processed, we need to get to a part that isn't processed because we haven't looked at this don't yet. Or even if we're in part of the string that we haven't processed yet, if we are in front of this do pointer, then it doesn't matter because don'ts only end a do, and so we have to keep going until we get after the string. So the do is going to go forward to a part that we haven't processed yet, and then the don't pointer is going to go until it's like over here somewhere, is the idea. Once we find that, we are then going to just pop that index here, or that range here, so that we know where this next enabled section is, and then we're going to update the process string index to the don't, which always ends things, so that we know that we've processed all of the string, and then we'll just keep iterating. I think there's some edge cases here, but, worked for my input, so didn't debug further. Now, this only really catches when we have a do and a don't that end, right? It can really only understand these. And so there's a case where, the final don't is here, but we actually have a next do, but we will have exited this while loop ahead. And so for this case, we're just checking like, if we're out of don'ts, but we do have a do left, we are just going to, use our same logic basically to find the next do that exists. And then if it's after where we've processed so far, then we're going to add that final range from the do to the end of the text. And so we're trying to catch that edge case. So we've solved for the edge case where we start as enabled, then we do all ones where there's a do and a don't that exists in the string, and then we do the final edge case where there's a do but no don't, so we have to just artificially end it at the end of the string, and that's all the enabled sections in the string. I'm not very proud of this code. I feel like there's some edge cases. There's probably an easier way to do this, but this is what I finally got working, and so this is what we're using. And then finally, we've got all the enabled ranges, but we do want to iterate over the string. And so what we do is we take all the enabled indices, and then we just pull them out into start end index. And then basically we just take the substring of all text from start to end index, create a list of these, and then we can cat them together to finally get a full string of only enabled sections that we can iterate on. And then of course, we iterate over only the enabled sections, pulling out the moles, and then we sum by the product here. Yep, and I got my answer, and it was accepted, so, works for my input. I think there's edge cases, but, probably works for most as well. Yeah, a few notes here. I'm not very happy with this code. It's super imperative. I feel like we missed some edge cases, but, it's a daily challenge. We got something to work, so I'm just kind of moving on from there. I did get hung up on a few edge cases here, and so I had to go back and take a look at some of the examples that they gave and run my code on it. I caught the edge case where we have to start as enabled early, but then dealing with the final do statement, I thought my algorithm solved for this, but it actually did not. And so I had to add this in later in order to get the correct answer. Next. So yeah, this one was a little tricky, and I really don't love my solution for this iteration. I feel like there's probably a more elegant functional way to do this, considering we're only really trying to pairwise compare the first do to the first don't kind of thing, but I don't know how to do that, so I just went with what I knew. And sometimes you just have to be okay with that, especially with these daily little challenge things. So if you have a better solution, I would love to see this, because I feel like there's definitely a better one out there. If you like this post, you might also like my solutions to day 2 or day 1 in F#, and you might be interested in how I got interested in F#, coming from a background of C#, TypeScript, Python, etc. So that's it for this video. Thanks for watching, and I'll see you in the next one.